Hey everybody, so here we're looking at a microwave. It's not what you typically would see on this channel, although I do on occasion work on appliances. So this is my mom and dad's microwave. It's a GE microwave from, I want to say about 2020 or 2021. I don't know for sure, but let me see if I can see a date in this thing. Okay, 2019. So it was actually manufactured January 2019. So it's a little older than I thought. But this is the modern day GE microwave, which is actually not made by General Electric. We'll talk about that here in just a moment. So the reason why it's here is because it has a problem. This thing, yesterday morning my mom went to use it, and when she was done heating up whatever it was, she went to close the door and the microwave started back up on its own. However, what actually happened was the light did not come on, the turntable did not run, and the fan in the back did not run, but the oven transformer and magnetron fired up. She opened the door, it shut off, closed it back, immediately started right back up. Again, same thing, just the magnetron and transformer, no fan, no light, no turntable. So she sent me a video, and I'll include it here in just a moment. Initially when I had watched the video on my phone, because she texted it to me, I thought that maybe it was the classic, okay, the fan running by itself, but no. Actually, it wasn't that. I initially thought it was microswitches, because microwaves, in the door mechanism, there are typically 3 or so interlock switches. This one has 3, and what they do is they prevent the magnetron from running in the event this door is open. And thankfully, those interlocks worked as intended yesterday. Because had they not, this thing very well could have continued running with the door open. Because my mom, with this thing closed and the magnetron and the transformer powered and running, I mean, she was pressing cancel and you hear it beep, 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 but it was not doing anything except running the magnetron. So, we're going to take the back off of this and we're going to have a look inside. Now, I do want to warn you, microwaves are dangerous to work on unless you know what you're doing. So, you definitely want to treat these with respect, because there is a high voltage capacitor in here that can hold a charge. Now, this one has a bleed off resistor on the capacitor. It's actually internal to the capacitor that will bleed off that charge. However, we do still want to use caution, and if you aren't sure if the capacitor has that bleed off, which I think most modern microwaves do, and it will actually say on the cap, if you aren't sure, you want to definitely use something that is insulated to discharge that capacitor. And again, if you are not familiar with this stuff, I strongly suggest you do not attempt what I'm doing here. I've actually worked on a few microwaves in the past, so it's not exactly new to me. So these microwaves, they have a tamper resistant Torx bit. Pretty much all microwaves have them. And I have this whole set of bits that I ordered on Amazon many years ago. You got all sorts of different tamper resistant bits in here, including the ones that I need. So we're going to pull this cover off, and I'm going to show you what's wrong with this thing. Alright, so we're going to pull the cover off the back of this. and we'll have a look inside. Good, we get some air. Kind of burning up because I just walked over here with this thing from my parents' house, which is a pretty good little walk. But alright, so down there is a high voltage capacitor, and it says on the side of it, well, this one don't actually, yeah, it does have a 10 meg ohm resistor across the two terminals, which will bleed off that charge. Alright, so I've already been in this thing once to identify the microswitches. That's why this one microswitch is just hanging out over here. But I'm going to go ahead and snap it back into place. Well, actually, before I do that, I'm highly suspect of this relay here on the control board. So that big guy is what sends power to this transformer, which I should note is in series with several different things, including the interlocks, which again prevented us from running with the door open. So right there is this relay, which again is like the gatekeeper to this transformer. This, the way it's supposed to work obviously, is the circuit board here will switch that relay on whenever there is basically a call for the magnetron. So let's say if you have your microwave on 100% power, you start it, it sends power to the transformer at all times. Whereas if you have it, let's say on 50% power, it cycles it on a duty cycle. That's why you'll hear your microwave, you'll hear the magnetron and transformer cycling on and off. You'll hear the hum of the transformer and then you'll hear the magnetron. So I'm going to pull off these connections here, and I want to test this relay. Okay, well, I managed to break free these connections here, but not first without you know, breaking this loose from the board. It's just a solder connection on the back of the board. Go figure. Okay, so I've taken a moment to test all three of these micro switches in here, and they all test good. So let me go ahead and explain how these work. So we have two that are normally open. You have the primary interlock switch, which is up top. This one kills power to the transformer down here. This one actually has primary 120 volts going through it. And when this one breaks, it kills power to the transformer. So let's say if this one fails to work. That's why we have the monitor switch. The monitor switch also monitors the status of the door, and let's say for example this switch does not work properly. So normal open, meaning that when the little push button on the switch itself is not pressed in, which is when the door is open, this switch shall be open. Okay, let's say for some reason it does not open. That's why we have the monitor switch. That one's normally closed. So when the microwave door is closed, that switch is open. That switch there basically is tied between live and neutral. Yes, live and neutral of the incoming power. And what this will do is if this one here fails to open, when this door opens and does not kill power to the transformer, and this is when the microwave is running, when this relay here is energized and sending power to the transformer, that one will blow. So that switch there is tied between the power output of this relay and neutral. So what will happen is if this switch here does not work properly, this one will actually close and short out the supply, which will trip your breaker in your house or pop this fuse back here. It's a means of killing power to this transformer if that door is open and this primary interlock fails to work. So the primary interlock did work as intended. It killed power to the transformer when the door was open. So that being said, I'm going to show you an example here. So the secondary interlock switch, which is the third switch down, that one is just connected to the circuit board. And what that does is it tells the circuit board that the door is open. That way it can kill power to this relay and pause the timer and turn on the light, all that good stuff. So with the microwave door closed, we have, that's hard to see, but the meter is reading 0.2 ohms. And as again, it's intermittent because barely got a good connection there. Alright, so when we open the door, no matter what I do here, that meter reads nothing. So that switch is working properly. So if that one, if the secondary interlock switch fails to operate like it's supposed to, what will happen is you'll open the door, the microwave will shut off, but the timer will continue to run. Alright, so the issue that we're having again is, for some reason, that relay, the power relay on the circuit board, was energizing the microwave transformer and the magnetron. So as you may have seen in the video earlier, my mom actually shot a video and sent it to me, and you could clearly see that the microwave light was off, the fan was not even running, but you could hear the hum of the transformer and you can hear the magnetron fire up, which is not good. Basically, it was running the microwave with nothing in it, and I'm going to talk about that here in just a moment. So, and this is why I think that these microwaves could have a hazard to them. So I'll test this relay again, and it's open. Alright, so what could happen here is this relay might be failing intermittently, meaning at times it sticks and remains in the closed position, but after a bump or whatever, or me, for example, trying to yank these wires out of it, might have opened it. It made it appear that it's working okay. We have a microwave at my place of work. It's a GE microwave that's just like this, and except it's stainless steel. And it's from 2022. It's exactly identically the same inside, because I've actually worked on it. So the issue that microwave has had was back in the fall last year. One of my colleagues, one of our instructors at the college, told me that the microwave was arcing inside. Had arced inside. And I was like, that's really weird. Of course, I'll go ahead and turn this around and show you inside, to show you what I'm talking about, since this is exactly the same microwave. So inside, you have what's called a waveguide. And you have this cover here. I think it's made out of like mica or something like that. It's right there, and it comes out. If that gets dirty, which that one's a little dirty, what can happen is it could actually cause issues where it will actually arc. So inside there is the magnetron's antenna tube. So the magnetron tube is inside here, and what can happen is, let's say, for example, the microwave runs with nothing in it. That microwave energy has nowhere to go. I was thinking, okay, maybe somebody was running the microwave with nothing in it, which I doubt. Most people are smart enough not to do that. But, I mean, some people may not realize why you should not run a microwave when there's nothing inside. That microwave energy has nowhere to go, and it ends up going back to the microwave itself. And let's say if this waveguide's dirty, it could definitely cause it to burn and arc and do all sorts of crazy stuff. So that made me a little suspicious, but what I did is I cleaned off this cover, and I looked at the magnetron tube, and it was burnt a little bit on the end, but I put it all back together and the microwave worked just fine. Okay, back in May of this year, 2024, I was told that the microwave was dead. And I went downstairs and I looked at it, and it was totally dead. Nothing at all. Like it is right now, basically. Nothing on display, no light, no nothing. What had happened was this thermal limit switch here had tripped, and it was open. Now this microwave uses a one-shot thermal switch. Some of them are resettable. Once they get above a certain temperature, they'll trip. But when they cool down, they'll reset. This one is a one-shot, so once it hits that specified temperature, it will trip, and that's it. And this here is in series with this one, which monitors the magnetron temperature, and if the magnetron overheats, that one will pop. So if either of those two open, it kills power to the whole microwave. Again, it was weird. I was thinking, okay, maybe somebody was running the microwave with nothing in it. Again, very, very odd. I ended up replacing this thermal switch, and that got the microwave back up and running. Again, that microwave at work never exhibited the issue of running the magnetron when it wasn't supposed to. It was weird. But it made me think, when this one had that problem where the magnetron was running with, again, with no call for the microwave to run at all, with the light off, looking basically like it looks right now. Made me wonder, is this relay here intermittently failing, causing this microwave to run the transformer and the magnetron when it wasn't supposed to, and therefore cause arcing inside and cause the thermal limit to actually pop. That thermal limit could very well have prevented the microwave from actually catching fire. And that makes me wonder, are these newer GE microwaves safe? I mean, thankfully the primary interlock switch prevented this from running with the door open, because that's all that was preventing it, those interlocks. Because again, with the relay closed, sending power to the transformer, the interlock was the only thing protecting my mom, for example, from getting exposed to microwave radiation. And because the thing is, that relay is not supposed to run when that door is open, because the secondary interlock switch will tell the board, hey, the door is open, don't run the microwave. So what I'm going to do is I'm going to pull this board out of here. I think what I'm going to do is I'm going to replace that relay. I just want to get a better look at it actually while I'm in there. Okay, so I'm going to take this whole control panel piece off here. I've already taken out the two screws that hold the circuit board in. However, there's two plastic clips in it that are also holding it in. So I'm thinking it's going to be easier to take the whole control panel out and then take the board off. So we got one screw up top here that comes out, and that is releasing the control panel. Hopefully I didn't damage the PCB, or the circuit board, rather, when I was trying to yank that connection off the relay here. Alright, and of course got one more connection here I didn't see, even though it was right in front of me. Alright, so we got the whole control panel out. And this little circuit board is the brains of the microwave. And thankfully we have the interlock switches there to protect the end user in the event that this decides to go rogue. So if we look here, you can see who actually made this microwave. Midea. I've had hit or miss opinions on Midea. I don't think they're exactly a great manufacturer. Of course, they're based out of China for one thing. And you know Midea is probably using cheap down Chinese junk in this microwave. Probably use a cheap relay. I wouldn't be surprised. Man, they made it really difficult to get this board out. Sorry I'm doing this off camera, but it's just, man, I mean, it's really in there. I've taken the screws out, and there's two screws I don't think I missed any. Alright, it's out. And look here, I did in fact knock loose this relay when I was trying to get it out, but other than that, it didn't cause any damage. So I'm going to desolder this relay. Again, we have, looks to be 4 connections. one there, one there, and one there, and one there. I'm going to do this off camera, so I'll be back in just a moment. Matter of fact, I broke loose 3 through-hole connections. Thankfully it didn't cause any damage to the board from what I can see. Okay, so here is the relay. Try to get you a closer look at it there. And it's the same brand as the Microswitch. Is this what is it called? Dongchun, whatever it is, some Chinese brand. The good news is Amazon has replacement relays, and it was $15 after tax, and I just ordered one. It'll get here in a couple of days, and I'll just go ahead and solder in that new relay, and that should get this microwave back up and running. The thing is, the concern I have is it's obviously a cheap relay, and what could be happening, what I'm thinking is happening, is it is intermittently sticking closed. That would explain why the microwave at work is exhibiting the symptoms that I discussed earlier, where it popped the thermal limit and caused the arcing inside. Because these relays, what can happen is these carry the current of the transformer, which in this case is probably about 13 amps, which is, yeah, that's, I mean, 13 amps on 120 volts AC here in North America. What can happen over time is if it's a cheap end relay, the contacts, every time they close and every time they open, there's a little bit of arcing that goes on. And what can happen is those contacts can weld themselves shut either permanently or intermittently. And that would cause what's happening here. Because my mom, she woke up and used the microwave, heated up whatever it was, and what she might have done, she might have just pressed the button on the, the door mechanism to pop the door open, which killed power to the transformer via the primary interlock, and stopped the timer via the secondary interlock. But when she closed the door, this relay being welded shut or stuck shut caused the magnetron to come back on. And it's a good thing my mom noticed this right away and shut this thing down, because it could have, like I say, it would have caused arcing inside the microwave, and it would have popped the thermal limit. So I have a suspicion that these relays are junk, and they're failing and causing potentially dangerous situations with these microwaves. I mean, relay failures are not, they're not uncommon. It happens, but this is the first time I've witnessed one, not just one, but 2 microwaves of the same model having the same symptoms. And I'm thinking the microwave at work might be having the same problem. It could be this relay going bad. So, there you go. Once I get the new relay, I'll videotape the footage of installing a new relay, soldering it in, reinstalling the circuit board, and putting this thing back together, and hopefully it'll work fine. Okay, so our replacement relay has arrived. This is what we get right here. So if we look at it, it is actually identical to the one that came on it, although the text on this one's a little different. So let's go ahead and change out this relay. Hopefully that should get this microwave back up and running like it normally should, and not running the magnetron when it's not supposed to. Alright, since the old relay came loose on its own, it came loose when I was trying to get these leads unplugged, we can just go ahead and install a new one, because the holes are actually ready to go. Otherwise you'd have to unsolder, or desolder rather, the old relay first. Alright, so let's go ahead and install this the same way as the old one. I'll go and crank up the soldering iron and get this soldered up. Okay, so the replacement relay is now installed. Although it's just a tad crooked. Not a big deal though, as long as it's in there. So I'm going to go ahead and put this thing back together. Okay, so I'm going to reinstall our control board. Line up the display. And line up these holes here. And there's a couple of snaps on the board. Now this one over here actually broke when we was taking the board out, but it's okay because we have 2 screws that also hold this in place. So we'll go ahead and put our 2 screws in. Don't need to be too tight, just make sure they're good and snug. And we'll go ahead and reconnect the cable that goes to the touch controls. Okay, so now go ahead and reinstall the control panel back into the microwave. Sorry if I don't get this all in view the best, trying to do the best I can here. So there's a couple snaps on the bottom down here, and then it's also secured by a screw, which is a Phillips head, like the screws that are on the circuit board. They're also Phillips. Pretty much everything inside this is Phillips. It's just the screws on the back are the tamper resistant screws. Freaking neighbors shooting off fireworks already. Okay, let's now go ahead and reconnect all our cables. Don't forget this little one here. I believe that's for our yes, that's for the sensor cooking. This little one right here. This one does have sensor cooking built in. It's a moisture sensor basically. Alright, we have this connection here, which goes down toward the bottom. And it snaps into place. Also got this one here that goes to the secondary interlock switch. But before I install that one, let's go and install our power leads to the transformer. You want to make sure that this one's good and snug, because this one carries the current that drives the transformer and the magnetron. I'm not the biggest fan of having spade connections in these kinds of things, because they're just not very good for carrying high amounts of current. But anyways, that's it. So I'll make sure I reinserted our manuals, service manuals, and it's kind of off screen. But this service manuals, it's important to keep them in an envelope. That way, in the future, if you go to work on this again or someone else works on it, all the wiring schematics and stuff are there. So now we are ready to put the cover back on this thing and test it. Make sure that just want to make sure I did reconnect our connections for our safety interlocks. Especially that monitor interlock, because you definitely want that one to work in the event that the primary and secondary interlock fail to work. Again, the primary interlock is the one that interrupts power to the microwave transformer, and the secondary interlock is the one that signals to the circuit board that the microwave door is open. But anyways, go ahead and reinstall this. Make sure the lips line up inside here, and they do. Okay, so now I'm going to go ahead and install our screws on the exterior. These are the ones that have the tamper resistant heads on them. Okay, now it's time to test the microwave. Okay, so now we're in the kitchen where we have 20 amp receptacles strong enough to handle a countertop microwave. What I'm going to do is I'm going to put this mug in there with some water. That way there's a load. Normally I wouldn't do this right away, but there is a chance that this thing could fire up immediately once it's plugged in. I want to make sure that there's load. Again, it should not fire up right away. That's what it's supposed to do. It's not start on its own. We should get a beep, and we should get something like a PF on the display there. And as you can see, control pad works. We got our mug in here. Let's just go ahead and start it. Transformer's on and the magnetron fired up. Let's try to cancel it. You see it cuts off. So we can see that the power relay is in fact functioning just like it's supposed to. We'll let this time out. That's going to be some pretty hot water. So you can see how this microwave killed power to the transformer magnetron first once the timer hit 0, and then a few seconds later it killed power to the light and the fan. And our water is definitely hot. So the microwave is working as intended. So we have successfully repaired this microwave. Hopefully this relay will hold up. Again, I feel like that's kind of a concern, having the relay go bad in this one, but not just that, possibly having the relay intermittently sticking in at least one or two microwaves in place of work. Yeah, there you go. Shut the door. Does not start up on its own. there you have it. So anyways, hope you enjoyed this video. Thanks for watching. Okay everybody, so I'm in the process of editing this video, which I shot back in the summer, and I realized that maybe I wasn't the most clear on the concept of how the microswitches in the microwave work. So you have your primary interlock and your secondary interlock, which are both normally open switches. So when the microwave door is open, those switches are open, meaning power cannot pass through them. But when the microwave door closes, those switches close in because the button on the switch is being pushed in, and it closes the circuit between the two terminals of the switch. So on the primary end you have your 120 volts or your 240 volts that goes from the relay on the control board through that primary interlock switch to the transformer. The secondary interlock is a low voltage switch. It's just a switch that tells the circuit board that the door is open. So the proper sequence of events of a microwave that has a digital control board, solid state control board, is when the microwave is running and you pull the door open, what happens is both the primary interlock switch and the secondary interlock switch, they open, killing both power to the transformer, and also the secondary interlock tells the board that the door is open, and the board disables power, or disables the relay, which also shuts off power. So you have both the power relay as well as the primary interlock switch. Those are two separate switches, the relay and the switch, that open when the microwave door opens. But let's say those fail. So we already had a bad relay in this microwave. Okay, what if that primary interlock switch also failed to open when my mom pulled the door open on that microwave? Okay, this is where the monitor switch comes into play. The monitor switch is a normally closed switch, meaning that when its little button is not pressed in, its terminals are closed together. So when the microwave door is shut, it opens. So the monitor switch is tied between hot and neutral. Okay, so when the primary interlock switch opens, the monitor closes at about the same time. So what that means is, if that primary interlock switch, okay, let's say if the secondary interlock switch fails, doesn't tell the control board that the microwave is being opened, or in this case the relay fails to open, okay, and the primary interlock switch also was to fail, that monitor would be the last resort thing to save you from being exposed to microwave radiation. So yeah, there's quite a bit of engineering that goes into a microwave oven, and these micro switches have been a common staple of the design of microwaves for many years. It's pretty common between all the different brands of microwaves. Now, microwaves that have, instead of having solid state digital controls, I'm talking about the ones, if your microwave happens to be one that has just a dial timer on it, a mechanical timer and a bell in it that goes ding when your food's done, those are a little different. Now the micro switches are, I think they're about the same. You do have the primary interlock. Not so sure about the secondary, to be honest. You might have a secondary to stop the timer, let's say when the microwave door is open, but those are a little different. So for example, when you close the door, you may notice on the microwaves how they just start right back up on their own. Those may rely more heavily on the primary interlock switch. I don't know for sure, but in this case, with this microwave, you have the two interlocks, the primary, the secondary, and the monitor switch, which help protect you from being exposed to microwave radiation if the door is open. Hey everybody, thanks for watching this video from Q channel. If this is your first time, please subscribe to the channel and tick the bell so you get notified of a new video I post. Please like this video if you enjoyed it, leave a comment, and share this video as well as the channel with your friends to get the word out. In addition, I have a second YouTube channel, that's QCompMTDX. Again, I hope you enjoyed this video, and thank you so much for your support.